The learning objectives of this section are to make shipboard operational personnel familiar with the anatomy and critical areas of the following main ship types: tanker for oil, bulk carrier, gas carrier, ferry, ro-ro vessel. Different ship types have distinct functional requirements depending on type of cargo and/or passengers to be carried, and one may consider fore and aft parts common to all except for ferry and ro-ro vessels. The ferry, ro-ro vessels must be considered separately depending on openings fore and/or aft, and drive-through arrangements. This chapter highlights the most common design features of some ship types and give input on critical structural areas to be inspected. We will now present the anatomy and critical areas of the following ship types: oil tanker, bulk carrier, gas carrier, ferry and ro-ro. Click the Ship Anatomy button and Critical Areas buttons for each ship type to get more information. The two main types of crude oil carriers are traditional single skin and the new design with double bottom and double skin. The main purpose with a modern design to avoid oil spills if outer shell is perforated. Double bottom will be a requirement for oil tankers carrying oil to US ports according to the Oil Pollution Act of 1990. The normal tank arrangements of a traditional VLCC single-skin oil tanker is 5 or 6 wing tanks at both sides with a centre tank in between. Some wing tanks are either clean ballast tanks or segregated ballast tanks. Fore and aft parts are not much different to other ship types, having ballast tanks forward and machinery spaces with tanks aft. The structural arrangements of a traditional single-skin oil tanker are transverse web frames crossing longitudinally different deck, bottom, sides and longitudinal bulkheads. One or two cross ties are fitted between the web frames in the wing tanks. A centre girder is fitted in the whole length of the cargo area, in the bottom of the centre tank. Oil-tight transverse bulkheads are vertically stiffened and with horizontal stringers. The critical areas for oil tankers are as follows. At end of brackets, tows and similar. High shear stresses at ends of span. At end of cross ties. in way of toes of brackets along centerline girder, upper part connections to deck of transverse bulkheads, ends of brackets, toes and similar of bulkhead stiffener connections, and horizontal girder connections. The two main types of bulk carriers are with or without cargo gear for self-loading or discharging in ports with no shore-based cargo facilities. The structural arrangements may be to single skin with double bottom and hopper and top wing tanks for ballasting. Some bulk carriers have double skin like OBOs. Problem areas to be given special attention on board a bulk carrier are upper and lower connection of main side frames, boundaries of transverse bulkheads and bulkhead stools, cross-deck structure, hatch corners and hatch combing brackets, localized cracking and buckling of web frames, and breakdown of coating in water ballast tanks. Inner bottom plating and hopper plating intersection. The most common liquefied gas carrier is the LPG design. That has an independent, fully insulated cargo containment system, consisting of a number of tanks located in a conventional hull, much like an ordinary bulk carrier. The basic hull of a gas carrier has much in common with the hull of a conventional bulk carrier, and will also have some of the same problems, such as hold frame connections to upper and lower wing tanks with regard to cracks only. Localized cracking and buckling of web frames caused by breakdown of coating and subsequently heavy corrosion in water ballast tanks. The intersection of the inner bottom plating and the hopper plating. Heavy corrosion on the inner bottom plating in way of the cargo tanks due to condensation. These vessels are characterized by large open spaces for easy loading and unloading of vehicles. There are mainly two different concepts: center casing structure. The access from the vehicle deck is through a casing placed in the center of the vessel. Side casing structures. The access from the vehicle is from the side of the vessel. The side casing may also be used for other purposes, for example, stores accommodation. The cargo access is normally through a bow and/or stern door, occasionally through the side of the vessel. The most dangerous situation is water on the ro-ro deck. This may cause rapid capsizing due to the effect of free liquid surface. That's why the tightness of the doors leading to the ro-ro deck is vital. In case of a collision, water may enter the ro-ro deck. In order to avoid spread of water to the whole deck, transverse bulkheads may be required, in addition to that of the conventional designs. The most dangerous situation is water on the ro-ro deck. There are two types of bow visors that are considered to be the main critical area of present ferry design, with ramp and bow door. Hellevice, the passenger ferry, does not differ much from a ro-ro ferry, both having open car decks. The most dangerous condition for a ferry with a bow visor is when the water is pouring in through leak closing devices, with danger for water spreading to the whole length of the car deck, and which could lead to instability and rapid capsizing.